Hi, good afternoon. Thank you very much for coming along to my session. So yeah, we're going to talk about HTTP today. I think this is a particularly interesting topic right now as we build out more and more microservices that talk over HTTP. Getting this right is really important in your applications. So my name's Steve. You can find me on Twitter. I'm at SteveJGordon. So I also blog, stevejgordon.co.uk. A lot of what I'm going to cover today I have blogged about previously in quite depth. So I've looked at the HTTP client internals. So anything that I cover today in this fairly short session that you want more information on, hopefully you'll find it there. You can find the slides. They're already online on this link. So if you want to download them now and follow along, that's fine. If you want to find them afterwards to get access to the code samples, you can do that too. So let's begin. So what we're going to cover in this session is we're going to have a look at a new feature that came out in .NET Core 2.1 called HttpClientFactory. So before we get to that, we'll find out why that's useful and what problems it's helping us solve. And then we'll see how we can actually use it to refactor some existing code to start taking advantage of that. Then we'll talk a little bit about the concept of outgoing middleware for our applications. So if you've done anything in ASP.NET Core today, you'll be familiar with the concept, hopefully, of incoming middleware, where your requests get processed through the middleware pipeline. Outgoing middleware is basically the same sort of idea, but it's for requests that you're making out of your application, and it's where you may want to do cross-cutting concerns with your HTTP code. We'll talk about handling transient errors. We'll talk about that briefly using a library called Poly. We'll look at some general HTTP patterns and practices, recommendations, and things that you may be doing wrong in your code today. Then we'll just have a brief discussion on what came in 2.1 in terms of HTTP client improvements and what's coming in 3.0. Just a reminder, I am speaking about .NET Core today, so some of this does differ if you're still working in .NET Framework. The stacks are similar, but there are some significant differences in certain parts of the discussion that we'll have. So we're going to start with this piece of code. So just briefly to describe what this code is doing, we've got an ASP.NET Core controller. Imagine this is a web API. There's an action method here, and in that method we're making a call to an external service. So in this case we're calling the GitHub API to get a list of repositories. We make the request. We then get the response and deserialize it. So this is some code that we're going to refactor as we go through the talk. But before we do, who's seen code like this today? Is this vaguely familiar to people in the room? Yeah, some? OK, good. So we're going to start sort of picking this apart and seeing what we can improve. The first thing I want to focus in on is this using statement around HTTP client. So this kind of was hinted at in the question you got asked before I started talking about disposing HTTP client. So HTTP client does implement the iDisposable interface, and that's typically a signal to us in sort of .NET that we should be disposing of that properly to ensure that any unmanaged resources are cleaned up when we finish using it. The problem is when we do this with HTTP client and we don't fully understand what's happening underneath, this can lead to some tricky situations. So HTTP client itself doesn't have directly any unmanaged resources, but it does hang on to a HTTP message handler chain. So this is a chain of handlers that are responsible for making your HTTP request over the network. And at the end of that chain is your outgoing network connection. And that's the resource that's signaled by this iDisposable interface that kind of cascades up all the way up to HTTP client. In this code, what we're doing is we are creating a new client. We're using it just for this action method, and then we're disposing of it when we're done, which in principle kind of looks OK. But if this gets called very often, we are creating and disposing clients very often. And what this means for us is that we're actually creating new connections every time we do this, because the underlying connections have to be re-established every time we have a new HTTP client instance. So this has a small performance overhead. We're creating new connections every time. If it's over HTTPS, we're doing handshaking. And all of that has to be established every time this action method gets invoked. And what we don't want to do is dispose of this, because when we dispose of this, what we're actually doing is releasing the connection. But the way that HTTP works is when we say we're done with the connection, it's not immediately released. The OS hangs on to that connection for a while in what's called a time wait state. And that time wait state lasts for around 240 seconds on Windows. So this is a period of time where the port that you were using to make your connection is effectively tied up. It won't be allocated to any other process or any other thing that needs to make an outgoing connection on that machine until the time wait period has expired. And this can be a bit of a problem for us because if we do this often, we're going to get a lot of connections that are sat in that time wait state. And when they're sat in that time wait state, we can't use them again. And what we will see this surface as is a socket exhaustion exception in our application. And this doesn't just affect our application, but it affects any other applications that are running on this server as well, because they also won't be able to get an outgoing port. There's around 16,000 ephemeral ports on Windows by default. And so that sounds like a lot of ports, but those can get used up very, very quickly. And so this kind of code, if called often enough, so either as we're doing here in an action method, which may be called very often, or in tight loops in your code base, can be problematic for you. So just to demonstrate what that kind of looks like, I took that piece of code and ran it in a tight loop 20 times very quickly. You can see all of these ports that were opened on my machine to a particular IPv6 address, and they're now all sat in this time wait state. They can't be used, and they're sort of essentially tied up resources on my machine. So what's the solution to this? Well, prior to .NET Core 2.1, the only real recommendation from the .NET team in terms of .NET Core was to reuse the HTTP client instances that you were creating. So by reusing the HTTP client, you're reusing that handler chain, and the connections that you've already established can be reused for further requests. And this is the best way to avoid socket exhaustion. So if we take a look at a typical way you might do that in an existing code base, here is a startup class for an ASP.NET Core application. In here I've got my configure services method, which is where I register stuff with DI. So one option, quite a simple option, would be just to register HTTP client as a singleton in this application, which means that I can reuse that same instance over and over again and can take advantage of reusing those already existing connections. So to make that work in our controller, what we would do is we would inject HTTP client in the constructor, and then we'd modify this code to make use of that. So the first thing we would have to do is we'd get rid of our own using statement. We're going to use the client that we've injected. But now we're presented with a problem here because we were previously setting on the client the default request headers. And this is set on the client, and it's not a thread-safe property. You can't be changing this if this code might be used across multiple instances, or sorry, the same instance of that HTTP client across lots of places of your application, because you may be affecting one another. So it's not really safe to set those on the header, on the client, sorry. So we'll set them on the per request basis for now. The last thing I would do then is just use the HTTP client directly. So this was the recommendation up until 2.1, and this would get us around the problem of socket exhaustion. But unfortunately, there is a bit of a side effect with this and a bit of a downside that may not be readily apparent. And that's that now what we're doing is we are keeping the same connections in use, potentially for the lifetime of our application. And so what happens is when we first make a call to api.github.com, we do a DNS lookup, we get an IP address back, we make our connection, and then we just keep using that existing connection. But what if that service moves or falls over and they fall over to a new server on a different IP address? Well, now our system's expecting to talk to something that's no longer there. We might also have been talking to something in the cloud that was on maybe on a blue-green deployment scenario. And in those situations, typically your staging and production environments might both be live on the internet, and it's just DNS that directs you to the correct production instance. If a service you're talking to flips the production and staging instances and you haven't refreshed your DNS entry, you're not going to get the connection to the correct server. So this is a bit of a problem, and there wasn't really a good solution until 2.1. And the solution, there were actually two solutions created in parallel. The .NET team were working on a solution that we'll talk about a bit later, but the ASP.NET team have come up with this thing called IHttpClientFactory, which also looks to solve the problem. And it solves not just that problem, but a bunch of things. So the first thing it's going to do is manage the lifetime of those handlers that I was mentioning. So the handlers that hang on to the network connections are going to get managed for us, and they're going to be refreshed by default every 2 minutes. And as a result of that, your connections are going to be refreshed every 2 minutes. So this gives us a kind of best of both. We're making sure we're reusing the connections for a period of time, so we avoid the risk of socket exhaustion, but we're not overusing them, we're not using them indefinitely, and we are going to pick up DNS changes when they occur, hopefully. The other things that this HttpClientFactory offers is a nice centralized place to provide logical configuration for HTTP client instances. So client instances that will talk to different downstream services that you may have in your application. It also helps codify that concept of outgoing middleware, and we'll take a brief look at that shortly. But it makes it very easy to attach these middleware components essentially to outgoing requests and apply cross-cutting concerns to your different HTTP client instances you may need. It integrates with a library called Poly, and we'll briefly mention what that does and how that can be helpful later on. And it also starts to build the foundation for improved diagnostics and logging that the team were able to wrap into the HttpClientFactory functionality. So if we want to look at how we actually get started with that, let's convert the code that we've just been looking at to start using it. And the simplest way to do this with the minimal changes is to basically just use it in a very simple form. And we'll look at that first, and then we'll look at the more complex scenarios. So in my code, in my configure services, what I'm going to do is I'm going to get rid of the singleton HTTP client, and instead I'm going to call this extension method add HTTP client. And what this is going to do is register in DI all of the services needed for the IHttpClientFactory functionality to work. So that simple change means we've got the functionality enabled, and this is enabled by default in 2.1. This is available to use. You can bring in the package from Microsoft.extensions.http if you are using a standard .NET Core application, like just a kind of generic host console app. But in ASP.NET Core, you can reference this automatically. So now in my controller, I'm going to make a few changes. The first thing I'm going to do is update my constructor. And what I'm going to do is replace my call, or my dependency now, so that I'm depending on IHttpClientFactory. And this is going to be injected for me. Now that I've got the IHttpClientFactory available, I need to create a client from it. So I'm going to use its method createClient. And that's going to give me back a brand new HTTP client instance. And every time you call that, you will get a fresh HTTP client instance. But what will happen is, under the hood, it may attach an existing handler chain if there is one available that hasn't yet expired. So that handler chain would be using an existing connection. Or if one has expired and there's nothing available, it will create a new handler chain with a new connection on the end of it. So this way, you're going to get the refresh functionality, and you can just create these HTTP clients whenever you need them. And then I can just make my call using that instance that I've just got access to from the factory. So that's like how you would start. If you have an existing application and you want to get the benefits of this kind of refreshing of connections, that simple change will just get you going, and it's not a huge code change to your applications, hopefully. But where the power starts to come is when you start looking at things like named and typed clients. So named clients is a way of providing this logical configuration for HTTP clients that deal with talking to a particular endpoint, a downstream service. So in this case, we're going to define a named client, and I'm going to use this overload that takes these two additional arguments. So the first is the name, which is just a string. So I'm going to, this client is going to be specifically for talking to the GitHub API, so I'm going to name it GitHub. And then I have an optional delegate that I can provide that allows me to configure the client. So when the factory creates the HTTP client instance, before it hands it back to you, it can run this delegate, and it can set things like the base address and the default headers that we need. Because we know we're getting a fresh HTTP client instance every time we request it from the factory, and we shouldn't be sharing those across threads, this now means that we're working in a thread-safe way. And by setting the base address and the default headers here in one place, it means that if those ever change, if the requirements change for talking to GitHub, it's one place that we have to update in our code. Now here I've defined one named client. You can define many of these. You can have these same calls one after the other for any of the endpoints you may be dealing with in your application code. So then to begin using this, in my controller we need to make a few other changes. The first thing is, originally we were making our requests to the full URL with the api.github.com on the front there. Now we're getting, or expecting to get, a client that's pre-configured for dealing with GitHub. We can instead change, and we just need to apply the path. The base address will come from the client that we ask for in a moment. These request headers that we were setting, these are common to all requests when you're talking to the GitHub API. And we've now set those as default headers on the HTTP client we've just configured. So we don't need to set those here. And then finally, when we call create client, we need to tell it which named client we actually want, in this case, the GitHub client. So now we're working with a client that's going to be handed to us from the factory, specifically configured for dealing with those GitHub APIs. Now, named clients are quite nice, but they rely on sort of strings and some basic configuration. What I really like about HttpClientFactory is their typed clients functionality. And this basically allows you to write a class that abstracts dealing with a particular downstream service and basically wrap all of the calls that you might want to make into some sort of abstract class that represents what you're actually doing with that service. And this makes it easy to have single responsibility for that functionality, and also to make sure you're sharing this across your application. So let's look at creating a typed client now instead. So this is a typed client. It's just a class. There's nothing special about this class. I've chosen to create an interface for it, but that's not required. I prefer to have an interface because then it makes it very easy to mock and test this typed client later on. And inside the typed client, the only thing I need to specifically make sure I do is accept HTTP client in the constructor. I can have other services injected there as well if I need to, but you must have HTTP client injected, and the HTTP client factory and DI system will make sure that that's provided to you. And in this instance, I'm choosing to set my client up in the constructor itself. So with typed clients, you can still use that kind of delegate when you're registering them, but I prefer to do this in the constructor now because this whole class is very much tied to dealing with the GitHub API. So I'm setting the base address and default headers again here. And then what I do in this type client is I can create as many methods as I need that represent dealing and talking to GitHub. So in this case, we're only actually just talking to a very specific endpoint where we want to get the repositories under the ASP.NET organization. So I've created a method that's specifically for doing that. And all of the code that we had previously has basically been moved into here now. So we've sort of abstracted that into a class that describes dealing with GitHub. So this means that we can now register this in DI. And so I'm going to get rid of my named client, and I'm instead going to register the typed client. So in this case, because I've chosen to use an interface, I can provide the interface for it and the actual implementation type as generic arguments. And now this is registered in DI in the similar way to what we just did with the named client. But what you'll see is we can actually start using this in a sort of nicer pattern now. So inside my controller, we're going to change this once again. This time we're going to refactor and make the GitHub controller accept the IHttp client. So now this will be injected for us, and it will be set up with a HTTP client instance from the factory. And now we've got a class that describes what we actually intend to do inside this application. Now my controller, my action method here can now be simplified because now we can actually work directly with that IHttp client. And so all of that code that I had here, which we've kind of moved into the IHttp client, goes away, and now we just call the method that we want to. This, in my view, is cleaner. Controllers aren't really responsible or shouldn't be responsible for lots of functionality for dealing with downstream services and deserializing responses. That's sort of not their responsibility. So what we've done is we've moved it into a class that has that responsibility, and now we can just call it directly from our controller. And our code in here has got a lot more simple. So let's move on and start talking about the idea of outgoing middleware. So typically when you make a request through HTTP client, this is the view that you sort of have of the world. So you have a HTTP request message, it goes out over the wire, hits an endpoint, and you get a HTTP response message back. What's actually happening under the hood is you've got this handler chain that I mentioned earlier on, and it's a set of handlers that will be called one after the other. Here I've described kind of two of the main ones, but there's actually quite a lot involved in this whole chain. And so what will happen in this scenario is actually HTTP client will call the first handler, which passes it on, and finally socket's HTTP handler in this case is making the connection and actually sending the request. The response comes back in and bubbles through. But what's useful about this is it means that we can inject our own cross-cutting functionality in the form of other handlers. And these handlers all have the opportunity to inspect the request message, maybe even modify it. So one example is you may call off to an authentication API or an identity server and get a token for authenticating to an endpoint. And then you might apply that to your headers. And you can apply this in a single place to any requests that go out through this handler chain. So then your requests flow through and your responses come back in. And again, you have opportunities on those responses to inspect them, maybe modify them, or do some validation or caching, that kind of opportunity there. So let's briefly look at how we would define a handler. So we create a class, and it derives from the delegating handler abstract base class. This has been available since HTTP client has been available, but what HttpClientFactory does is it makes it easier to register this and a bit more sort of simple to use. So my class in this case is going to accept a service. You don't have to, but it can accept services via dependency injection. And the main thing that I've got here is this override of the sendAsync method. And this is the piece of code that's actually going to kind of accept the request message and eventually just pass on the response. So in this case, I'm calling immediately into base.sendAsync, which passes the request on to the next handler in the chain. I could do some work before that. I haven't done in this case, but I could do that authentication work and change headers or validate headers there. And in this case, what I'm doing is when I get the response back, before I pass it on to the previous handler in the chain, I'm going to make sure I log out its status code. So it's a very basic example of what you might do with a delegating handler. And to register this, when you add a HTTP client here, what you get back is a HTTP client builder. And that lets you chain together services to build up how that HTTP client instance is actually going to function. So one option we have is we can call this method add HTTP message handler and then pass the type of the handler we want to attach. And now anything that comes through this typed client will also fire through that handler that we've just generated. The other important thing that you have to do is register that in DI as a transient service so that it all can be wired up properly. And so in this scenario, we've applied a cross-cutting concern to a particular typed client. Now, the other thing I mentioned that's important is thinking about resiliency. And with HTTP, there's often the possibility of transient failures down the line that could affect us actually getting the response back. Servers can temporarily go offline, or the deployments might be happening, and very briefly, you might not get the response back. And so to deal with that, we can use a library called Poly, which is around fault tolerance in your code. And it's not just for HTTP, but it's a really nice fit for HTTP requests. And it basically gives you the possibility to write a policy which under certain conditions will apply to a piece of code that you're executing. And the Poly team and the .NET team have worked together to integrate HttpClientFactory and Poly. Now, I don't have time to talk about Poly today in this sort of brief talk, but there are lots of different policies you may have. The most common would be something like a retry. So if you make the request and you get back some kind of 500 error, temporarily unavailable error from a server, it might make sense that you retry the request in maybe a second or two. And so doing a retry means that you can ensure that your application can give it a few more goes before it actually has to report back a failure. And often that will get you over most transient issues. So to work with Poly in the HttpClientFactory, what we would do is, again, on the HTTP client builder, we can call another method, add transient HTTP error policy, which registers a policy that we're about to define that will take effect whenever a transient type HTTP issue occurs. So in this case, I'm defining a wait and retry with a maximum retry count of 3 times. And in this one, we're actually doing an exponential backoff. So every time we get a failure, we're going to wait a little longer before we try again. And this allows us to deal with those kind of transient type issues in a fairly nice and simple way. And again, this applies to every instance of that typed client that you will get. So I just want to move on to some other sort of important points that you should think about when you're working with HTTP and HTTP client. The first is taking care of response content. In this code, this might look perfectly fine, and it might look very common. We're reading the content back as a string so that we can take the JSON string and pass it into JSON.NET and convert it. The problem with this code is this allocation over here of a string, which could be huge depending on the response content. And actually, we don't really need that string for anything but a transport into JSON.NET. But JSON.NET supports working with the stream directly. And so it's much better to actually avoid the unnecessary allocation of a string there, which is, if this is called often, potentially going to add GC pressure to your application, and actually instead work with the streaming APIs. And it's not too complicated, it's a few lines of code, but the easiest option is to use the read as async method here and pass the type. And under the hood, the Microsoft team have written a library that will actually handle passing that into JSON.NET using the stream and avoid the unnecessary intermediary allocation of a string. And so that's worth looking at, particularly if you're dealing with sort of large content types or endpoints that could be compromised and someone malicious might inject a very large response back. The other thing I want to briefly touch on is handling errors. So we talked about transient errors, but what about 404s and things like that? We're doing a GET request here. We haven't checked that this has actually succeeded before we try and deserialize the content. And there might not be any content if we've got a 404. So you should always make sure you check these. One option is the ensure success status code, which will throw if it's a non-200 status code. Obviously, that then exception is going to bubble up to your caller. You might not want that. So another option would be to ensure you call the is success status code to check whether it was successful or not, and then conditionally return either the deserialized response or just some kind of default. The final thing I want to touch on is cancellation. So one way to improve the performance of your application is not doing work you don't need to do. And so what we can do is use cancellation and async await to our advantage here. The HTTP client methods are all asynchronous, so what we could do in our type client is accept a cancellation token, and we'll worry about where that comes from in a moment. But then what we can do is make sure that maybe before we even try and make a request, we'll throw if cancellation requested, so we won't even bother establishing a connection if we were going to, if they cancelled very early. And then we will also pass the cancellation token through into those async methods. The important bit here is we're working with an action here. How do we get a cancellation token that's of any use? Well, some people don't realize that in ASP.NET Core, you can accept a cancellation token as an argument to your method, and that will get actually wired in when the action invoker for ASP.NET Core passes a request to your action. So it will be tied to the request that's come into your website, and if they cancel and move on, this cancellation token will signal that fact. And so we could pass that cancellation token through and avoid doing any work that we don't need to be. So the big question that was hinted at the start, really, when should you dispose of HTTP client? And it really does depend. It really depends on what you're doing and how you're using HTTP client. So I'll sort of give the kind of contractor answer there and then charge a bunch of money to tell you the exact reason. Or I can give you this slide which summarizes some of the core possibilities. So if you're using HttpClientFactory, disposing of HTTP client has no real effect. It doesn't hurt to do it, but actually HttpClientFactory is managing those handler chains for you. And so even if you dispose of HTTP client, it's not going to get rid of the handler chain because that's still bound up in DI and still will be available for reuse based on how HttpClientFactory is managing it. So if you're using HttpClientFactory, it doesn't really matter if you do, but it has no effect. If you're not using HttpClientFactory, then as we sort of talked about earlier, the general advice from Microsoft is generally never dispose of it if you want to make sure your connections are reused. But again, depends on how many HTTP calls you're making and whether you want to do it. If you're doing it infrequently, you may still want to dispose of it normally. And then the other two types that implement iDisposable, HTTP request message. This one's a little more tricky, and it only really has an effect if the content you're sending is a stream. Then if you dispose of HTTP request message when you're done with it, the underlying stream will be disposed of for you as well. But you need to decide if that behavior is correct for your application. That might not be right. If you've been passed the stream by someone else, you may not own it, and it might not be the right position for you to automatically dispose of that stream because other people may need it. And finally, the response message. The general advice from Microsoft is it's generally safest to always dispose of this one. In most cases, it's, again, not going to have much of an effect because generally what happens is when the content is read in by HTTP client, the entire content is pre-buffered into a memory stream, and at that point, the connection's released to do other work. So once it's in a memory stream, then that's not actually tying up any unmanaged resources anymore. So you can dispose of it, but all you're disposing of is a memory stream. But if you're doing work that changes the HTTP request options, then you might be actually only asking for the headers to be read rather than the full content. So let's look briefly at how we would implement iDisposable properly with the request message, sorry, the response message. So the idea is we get the response, and then before we actually start doing work with it, we would put it in a try finally block to make sure that even if that has an exception, we properly dispose of it down here. In this scenario, it's not going to have any real effect. But if I went and made my send async call with HTTP completion option response headers read, what this is saying to HTTP client is don't pre-buffer that content into a memory stream. And that ties up that connection until you've said that you've read the content. So in this scenario, you would want to use the try finally to make sure that when you're done, you're releasing the content and allowing it to move on. So I said that there were some other changes in 2.1. The sockets HTTP handler was introduced by the .NET team. And so this also provides somewhat of a solution to the problem of the DNS refresh, because what the .NET team have done is with 2.1, they've implemented a new managed handler called the sockets HTTP handler. And so instead of calling the underlying operating system to make HTTP calls, so before they were calling WinHttp on Windows or libcurl on Mac and Linux, they were actually just passing them the responsibility of making the request. The team found that actually on Linux the performance was really bad. And to get parity, what they've done is create a managed handler where all of the actual code for making the HTTP request is now in managed code. And it uses the sockets API to actually use raw sockets to actually send that over the wire. So now a lot more of the HTTP functionality is in a piece of managed code. The team can start making improvements to it. And one of the things they've done is implement connection pooling in there. So this makes sure that all of your connections will actually be recycled every 2 minutes by default if you're using .NET Core 2.1. So this is useful. It's enabled by default in 2.1. It doesn't get rid of the usefulness of HttpClientFactory because that has all the benefits of the things like the typed clients and the easy configuration of the delegating handlers. But the two together work perfectly well. And then finally, I want to just briefly touch on what's coming in .NET Core 3.0. So this is sort of on the horizon. In the next couple of months, we should have a sort of the first supported early preview of the product, and then by the end of sort of September, October, we should have the release of 3.0. So one of the things the team have been working on is HTTP2 support, which was missing in 2.1. and was one of the limitations that meant that some people couldn't take advantage of the socket HTTP handler functionality if you needed to talk to endpoints over HTTP2. But within 3.0, that is now supported, although they haven't implemented absolutely everything. They've implemented enough to make this work for gRPC. So gRPC is gRPC Remote Procedure Call. And this is a new sort of server-to-server technology that's starting to get some traction, and the ASP.NET team are working on quite heavily to ensure that they've got a modern scenario for doing sort of microservice communications. And that, as its underlying transport, relies on HTTP2. So what the team have done is they've had to go in and sort of engineer the socket's HTTP handler to support the functionality needed for that. So that isn't going to be enabled by default, but you'll be able to set that either at a per request level or at a HTTP client level. And they've implemented a new property on HTTP client called version, which lets you tell it which version you want to be using, 1.1 or 2.0. So if you're using something like HttpClientFactory, again, that's something you could configure on your clients, either in your delegate or in a typed client in the constructor against a particular client, and you can create a client that's suitable for talking over HTTP2. And that's exactly what the ASP.NET team have done to create a client that works for gRPC scenarios. The final change that's coming along as well is TLS 1.3 has been added in, and OpenSSL 1.1.1. That will be ready and available for Linux, which already supports working with those today and has improved connection times and improved security. On Windows and Mac, they don't actually implement those yet, but when those OSs do, this will light up and be available as well. So let's summarize quite a sort of rapid-fire set of information. The first is use HttpClientFactory. If you're on .NET Core 2.1 or above, there's no good reason not to use it. You've got all of the functionality like the typed named clients, easy integration with things like Poly for handling transient errors. It's really worthwhile starting to look at how you can take your code over to that. Do look at using Poly. As I say, retry policies are a basic example, but there's things like circuit breakers you may want to use to back off from downstream systems if they're struggling, things like that. Do think about this content.read and string async and the client.getString async methods. Those will allocate a string. That might be a large string. It could end up on the large object heap, and that might be a problem for your application if it happens often. Do expect and handle errors from services you're talking to, even your own internal ones. They will do weird things, and if you're not handling them properly, your application may fail as well, and that could cascade through. Passing cancellation tokens is a good way of stopping doing work that you don't need to. It's a common pattern in async await. It's just worth making sure you're wiring that through from your ASP.NET Core controllers if you need to. And generally just go off and hopefully start changing your code and enjoy HTTP client. So that's it from me. Thank you very much. Again, my contact details there. I've got a YouTube channel as well, and I've got some Pluralsight courses, or one at the moment, 2 coming soon, hopefully, if you want to check those out. So we're going to move on to questions. Before we do, I'll leave these up so that you can kind of grab a screenshot. Again, the bit.ly link to these slides. There's 3 blog posts on my blog that I've drawn out, which all talk about sort of disposing of the HTTP client, the request message and the response message. So if you want to see the detail, I actually look at the internal implementation of those types so we can understand what they're doing, which kind of helps us understand what's the right thing to do for our own code. This blog post by the ASP.NET Monsters kind of describes that socket exhaustion exception issue that I mentioned earlier. The official documentation talks about how to use HttpClientFactory and expands on the samples I've shown you. And finally, the GitHub for Poly, they've got a really good wiki on there that describes exactly how to use Poly and the libraries there. So I think that's it from me. We're open to questions.
Thank you very much, Steve. So, any questions? Here we go.
Hello, thank you for your talk. Is it possible to use HttpClientFactory without ASP.NET Core, where I can obtain an implementation of interface?
So the Microsoft extensions.http package is on NuGet, and it is a .NET standard package, so you can bring it into older applications, but you are tied to using their DI system as well, so you would need to at least wire it up initially on their DI container. There is a sample, so Glenn Condren, who's one of the guys from Microsoft who's worked on this, he has got a sample on his GitHub repo of using it in a .NET framework. I think it might be a web forms application, I'm not sure, but he's got an example of wiring it up there in an older application. So it is possible.
Okay, thank you. And second question, what about...
Sorry, let's see if maybe other people have questions, and then...
Oh, okay.
So any other questions? Here you go.
Hello, thanks a lot for the talk. My question related to the socket refresh that you have mentioned. It takes about 2 minutes by default. And what happens if we have a blue-green deployment that actually appears in this time frame? So the request will go to other machines.
Yeah, so what will happen is it will try and make a request to the connection it had, which will potentially still go to the old system. So if you know what you're talking to and you know how frequently it might deploy, you might change that to maybe a 1 minute interval if necessary. And that's possible with the kind of the configuration of the logical client. So you could create a client for your very specific needs. I think they were talking about whether they could have some kind of signal in to sort of say, for a particular client, I want to refresh now. So your downstream system could, on deployment, do some triggering, but that hasn't been, I haven't seen that since they originally mentioned it in an issue somewhere.
Okay, thanks.
Okay, what about H2C, HTTP2 without encryption? Will it be supported in .NET Core 3.0?
HTTP2 without encryption?
Yeah.
I don't think can you do HTTP2 without encryption?
I don't think so.
No, I think it has to HTTPS. Yeah.
In early RFC drafts, HTTP2 is only TLS protocol, but in final RFC, it's probably null.
Okay, if that's the case, I haven't seen that, no, so I'm not sure. I believe, as what I've seen in the client at least, is that it will just default to requiring some kind of authentication.
Okay.
All right, next question over there.
So my question is, why was the reason not to use pattern like in DB connection and .NET team came up with HttpClientFactory? So in DB connection, we have disposable DB connection and internal pool, which is maintained by the system. But in HTTP client, we have to use HttpClientFactory.
I'm not sure what the original reason was. I think it was just probably the port of things over to core. There was a lot of functionality that was originally missing, and they had to rebuild the stack to work with it. And so it was kind of a problem that then the .NET team and the ASP.NET team were trying to solve at the same time, and that's why in 2.1 we kind of have two solutions for it. But I'm not sure of the exact internal sort of reasoning.
Thank you.
Okay.
Any other questions? Then I got one. So in the first scenario, when you use the HttpClientFactory, right? Then as far as I understand, if you call the create client in a hot loop, you're gonna get the same kind of underlying connection, right?
You should do. Yeah, you'll get a new HTTP client, but the handler chain that's in there will be the same.
But what happens if this is a really tight loop and you are actually sending a lot of requests in parallel? You cannot use them on the same connection, right? Because the underlying connection is not multiplexed.
Yeah.
So how does it work?
So it will open new, if there's one already in use that it can't use, it will get a new port and make a new connection. But
all right. So the factory gets track of the connections and then it
client
gives
itself will do that automatically. So if you try to do two parallel requests to the same endpoint, it will probably create two connections to that endpoint. But what it ensures is that the connections aren't closed. They're released back into the pool and can be then reused for the future ones.
okay.
So it is possible you could still run into a problem if you're in a really tight loop and they're all firing at the same time. Then maybe you could still run into socket exhaustion that way, I think.
I need to check it. All right, any other questions? The last one?
if I want to close my connections, can I do it? How does HttpClientFactory closes those connections?
I don't think it exposes any APIs for you to do it yourself. So it will just be on the time limit that you set when you configure the clients.
Well, I guess that's it. We are out of time for the questions. Let's give a warm round of applause for Steve.